Okay, next up, we're going to be writing a geometric proof. So the statement that we're trying to prove is if angle FGJ is congruent to angle JKG, and angle JKG is congruent to angle KGH, then x is equal to 6. And for this one, we also have a picture. So we've got a picture to look at over here on the side. Okay, so there is a 2-column proof process for this one. We talked about the 2-column proofs. Now, if you're feeling pretty good about this, or if you really want a little practice with this right now, this would be a good place to pause the video. All of the statements are included in the correct order here. And so you could use this to try to figure out what the reasons are that go along with that. So if you wanted to pause the video and see if you can fill out that proof, and then come back and we'll go over it. All right, so the first thing that you write in any proof is the given information. So with this one, given within the statement was that these two angles are congruent to one another, and these two angles are congruent to one another. And this information was given in the diagram. So that's looking from over here. Angle FGJ is 6x plus 7 degrees, and angle, what do they call it, JKG. Oh, that is wrong. We're just going to fix that. Oh, KGH. I'm sorry. It's in there. KGH is equal to 8x minus 5. So our given information is there. The next step, it shows that the measure of angle FGJ is equal to the measure of angle JKG. And the measure of angle JKG is equal to the measure of angle KGH. So looking from the previous statement, I see that it shows that those two pairs of angles are congruent. And so the reason we can say that their measures are equal is because the definition of congruence, definition of congruent angles, tells us that they are equal. Okay, next step. The measure of angle FGJ is equal to the measure of angle KGH. So looking at the previous step here, FGJ is equal to KGH because both of these two angles are congruent to JKG. So this would be the transitive property. Now the next statement says that 6x plus 7 is equal to 8x minus 5. So looking at the previous step there, the previous step tells me that FGJ is, the measure of FGJ is equal to the measure of KGH. So if I go back up and look, the measure of FGJ is 6x plus 7, so that was just replaced. And KGH is 8x minus 5, so again, that one was just replaced with what it's equal to. So this would be the substitution property. Now the next step goes into some algebra here. So we're going to go back to using our algebraic properties from yesterday. So looking at the previous step to this one says 6x plus 7, and then it goes to 6x plus 7 minus 6x. And this side says 8x minus 5, and this side says 8x minus 5 minus 6x. So this would be the subtraction property of equality. Now in the next step, they just did the calculations for each of these. So combine the like terms, that leaves just 7 on the left. Same thing on the right, combine the like terms, that leaves 2x minus 5 on the right there. So when you combine like terms, essentially you're replacing each side with something that it's equivalent to. So that would be substitution property. Now in the next step, I see that it looks like we've added 5 to each side of the equation. So from the previous step. So that would be the addition property of equality. And the next step after that, they combine like terms again. So that would again be the substitution property. Okay, from this step to the next one, both sides of the equation were divided by 2. So that would be the division property. And in the next step, they perform those operations. So performing the division on each side, which means we're replacing each side with something that it's equivalent to. So that would be the substitution property. And then the last one there, x equals 6. From the previous step said 6 equals x. So if this is x equals 6, that would be the symmetric property. And x equals 6 is what we were supposed to prove. That was in the original statement. If this, then that.